All right, we're starting our unit on parallelograms, or sorry, quadrilaterals. Quadrilaterals, what does quad mean? Four. Lateral means lines. I was right, I guess sides now. Okay, quadrilateral is a closed shape with four sides. There are 1, 2, 3, 4, 5, 6, 7 different types of quadrilaterals. Concave quadrilateral, kite, etc. This chart is pretty cool. If you'll notice, if you think of this as a tree, you have a branch going off here, a branch going off here, a branch going here, and a big branch here, with quadrilateral being the root. Everything leads back to quadrilateral. So for example, a kite is a quadrilateral. a trapezoid is a quadrilateral. A square, though, is a rhombus, it's a rectangle, it's a parallelogram, and it is a quadrilateral. Anything below a shape is also that shape. So for example, a rhombus is a parallelogram and a quadrilateral. But is a rhombus a kite? No, it's a different branch. Okay? It reminds me of the evolutionary tree. Definition, now we're going to do parallelograms. Definition of a parallelogram is the four sides, the opposite sides are parallel. This is parallel to this. This is parallel to this. Opposite sides are also congruent. This is the same as this. Oh, wrong markings. This is the same as this. This is the same as this. For example, if this was 3 centimeters, this one would be, if this was 6 centimeters, this one would be 6 centimeters. Opposite angles are congruent. This is the same as this. This is the same as this. If you notice, this is an acute, this is an acute, this is an obtuse, this is an obtuse. The two acute are equal. The two obtuse are equal. Congruent means equal. Or equal measurement, I should say. Diagonals bisect each other. Bisect means split in half. So if we have two diagonals, one diagonal here, split in half, or I just wrote in half. This diagonal here that diagonal is the same as this diagonal. Those are the same diagonals. Well, sorry, they're not the same. They're splitting each other in half. So that means this is the same as this. This is the same as this. If this was 3 centimeters, this one would be 3 centimeters. If this was 6 centimeters, this one would be 6 centimeters. This is an extremely important property of parallelograms. It's one of those properties where no one really knows about it, but it's actually probably the most helpful of them all. That these two diagonals bisect each other. Lastly, consecutive angles are supplementary. Consecutive means on the same line. If you notice, these two angles here are on the same line. They're on this line right here. What about these two? Are these two angles on the same line? Yeah, so those would be supplementary, or add up to be 180 degrees. So they add up to be 180 degrees. This plus this equals 180 degrees. Do you notice how it's an obtuse and an acute? If it's an obtuse and acute angle, they equal 180 degrees. So an obtuse plus an acute equals 180 degrees. There should be note cards. You need to keep your note cards. Are there note cards around somewhere? Everyone grab you a note card. There should be a pile of them. Oh, here's a pile of them. Here. This, I think they grabbed them. Oh, we added note cards. Okay, once you get your note card, fold it hamburger. So fold it side to side, and then fold it up and down. I think it's 2 hamburgers. And when you open it, it should look like this. You have 4 equal sections. You go this, and then you do this. Okay, the next thing I'm going to do is I'm going to create, if you notice, what did these folds do? These folds made it so that we have a spot in the middle of the card, right? I'm going to mark that spot in the middle of the card. I'm going to mark it like this. I'm going to mark this one here. I'm going to mark this one here. I'm going to mark this one here. That's solely so it's easier to see. Okay, what we're going to do now is we're going to create our own parallelogram. So parallelograms are pretty hard to make, and chances are yours won't be a perfect parallelogram. That's okay. You can be off by a couple of centimeters. I don't think I've created a single perfect one yet. Okay, but how do you create them? A lot of people, when they make parallelograms, they start off by doing the sides. That is probably the hardest way to do it. It is so much easier if you use the diagonals to make a parallelogram. What do I mean by that? Take your card, take the long side, draw a straight line using the long side. Before you lift it off, you want to make a small marking on where the middle is. Use the marking on the card to do that. It's somewhere. So it looks something like this. Thank you. Okay. Take the index card again. Instead of using the long side, we're going to use the short side, and we're going to create another diagonal. Line up your 2 marks like this. I'm lining up my 2 marks like this, and then I'm going to draw another line. Mine's a little bit off already. Okay, if we truly made 2 bisecting diagonals, we should be able to measure them and see that they're the same measurement. This should be the same as this. This should be the same as this. So I'm using centimeters. I'm using centimeters. I'm using centimeters, not inches. Centimeters. What am I using? Centimeters. To measure it. I got 6.2 here. And then I'm going to get, it looks like looks like another one. And I got 6.4 here. Mine's really off. Then there's a super, super off. How did I do it? I measured it. Used one side of the card for one and the other side for the other. It's this. And then this. That's okay. And then for the other one, I got 3.6. And then this one is 3.9. So this is a particularly not parallelogram. It's not that big of a deal though. And in a perfect world, should be close-ish to mine. In a perfect world, these would be perfectly even, right? This would be the same as this. This would be the same as this. Chances are that's not going to be the case. Let's finish drawing our parallelogram. We need to connect the ends. And connect this end here. Need to connect this end here. Oh man, it's so off. Need to connect this end here. And then I need to connect this end here. Most people's numbers will be off. So there's my parallelogram. Is my parallelogram perfect? Obviously not. In fact, I can tell already, look how off mine is. This needed to be like all the way down here. What? I think you can figure this one out on your own. Okay. If we also did this correctly, this should match this, and this should match this. These should all be matching. Let's see if I did this correctly. This one is 3.8. This one is going to be way off. This one's almost 4. This one is 9.6. And then this one is 9.3. The sides. Oh no, this one's 9.5. Okay, so in a perfect world, if we actually did this correctly, which I don't think anyone has yet, these should be the same, and these should be the same. You gotta measure them. You don't have a choice. This will be for a grade later. Okay, a couple more minutes. We have to go fast for a reason. What? You came out the same? Yeah. Excellent job. Good. But they should, in a perfect world, they'll be exactly the same. Most people won't get it exactly the same. Okay. Next one we're going to do is rectangles. You guys want to hear the joke I've been saying today? You guys want to know what my video game name is? Rectangles. Want to know why? Because I wreck you when we tangle. You're welcome. You can steal that one if you want. Okay. All right. So what is a rectangle? A rectangle is a parallelogram. And since it's a parallelogram, it has all these properties above, all the same properties above. But additionally, it has a few more. The definition of a rectangle is a parallelogram with 4 right angles. These are the 4 right angles. Its sides are perpendicular. And most importantly, its diagonals are congruent to each other. Its diagonals are congruent. No. Okay. The diagonals are congruent. That means this here is the same measurement as this here. But more importantly, way more importantly, this is the same as this. This is the same as this. All of those should be the same measurement. Okay. We're going to draw our own rectangles. We're going to use it using the diagonals again. You have a choice. You can either use the short side or you can use the long side. But do you remember how in parallelograms we went long side, short side? Right? In parallelograms we went long side, short side. Now we're either going to do short, short, or long, long. It doesn't matter. You can either go short side, long side, long side. Which one do you guys want to do? Short side is probably a little easier. But the point I'm trying to make is you can make them using diagonals. We all know you can trace this and you'll get a rectangle, right? But my point, you have to wait a little bit longer. My point is that we're trying to make it with diagonals. So what I'm going to do is I'm going to start off with this diagonal here. I'm going to draw a line. Oh no, mine's bad already. It's a bad bear. So that's the, and then I'm going to mark the middle, because remember the diagonals bisect each other. Well, because I didn't do it perfectly. Next one I'm going to do is using the same side, I'm going to draw another one. Try to make it a little bit narrower. It makes it a little look better. Line it up so the diagonals bisect each other. And then draw this. Man, I am just not doing a very good job with this. All right. So what we're going to do now is we're going to check to see if these are the same length. This is about 4 centimeters. This is going to not end well. This one is about 3.8 centimeters. Good. This one is going to be about 4 centimeters. And then this one is going to be about 3.8 centimeters. So in a perfect world, what should these all be? All the same number, right? Probably 3.9, 3.9, 3.9. Actually, we could figure out exactly what it's supposed to be. Okay. We measured these. Now we're going to connect our ends to make our triangles, our rectangle. Connect this, connect this and connect this. There's our rectangle. And if we did it perfectly, we should be able to measure this, and they should all match up. Mine's 7.5, and then this is 7.3. This one is 2.7 and 2.6. Okay. This is going to be for a grade. You have to get these all done. You have to make sure both of those examples are drawn and labeled and measured. Yeah, it's fine if it's bigger. No, it's due tomorrow, actually. All right. This is a small class. All right, I need to start uploading this.